All right, hi everyone. So this is a question, a very common structure and bonding question that comes out in your exams. Okay, so I'm going to teach you how to answer this easily. So the diagram below shows the structures of substances X, Y, and Z. Okay, you can see these three substances. Okay, substance X and Z, so these two, they are considered to be allotropes. So define the term allotropes. If you look at substance X and Z, right, you can see they have the same atoms. Okay, they have the same atoms from the same element, but what is different is their structure. Okay, so what are allotropes? Allotropes are different structures formed by the same element. Okay, they are different structures formed by the same element. So next, hence identify which of the above substances could be graphite and diamond respectively. Okay, so graphite and diamond, right, they are both giant covalent compounds. Okay, what is different is their structure. So graphite, it has this hexagonal structure between the layers, and then diamond, it has a tetrahedral structure where one carbon atom is bonded to four other carbon atoms. So if you look at substance X, well, you have one atom bonded to four other, and it forms a tetrahedral structure. So substance X is diamond. Okay, then if you look at substance Z, it's a hexagonal structure, and there are layers. Okay, there are layers between each other. So Z is graphite. Okay, now here comes the part where most students struggle with, explaining the melting points. So let's look at part B. Substance X and substance Y, they have large differences in their melting points. So with reference to the structures and bonding, explain the large difference in their melting points. So we have to use structure and bonding. What are structures? Structures are like your simple covalent structures, your giant ionic lattice structures, your giant covalent structures. So first we need to identify the structure of X and Y. If you look at substance X, right, it's a very small molecule, right? You can count the number of atoms. It doesn't look like any lattice structure, so it's probably going to be a simple covalent structure. Okay, so substance Y has a simple covalent structure. Then look at substance X. We already discovered that substance X is probably diamond with this huge tetrahedral structure. So substance X has a giant covalent structure. Okay, that is how I determine the structure and how I use it to explain in the question. All right, so substance X has a giant covalent structure, okay, but substance Y has a simple covalent structure. So now that we identified the structure, we can explain in terms of bonding. So what is the bonding for simple covalent molecules or simple covalent compounds? They have weak intermolecular forces of attraction between the molecules. Okay, intermolecular forces is weak. And then what about giant covalent compounds? They have strong covalent bonds between the atoms. Okay, so that is exactly how you want to phrase it for the bonding. Okay, so there are strong covalent bonds between the atoms in substance X. Okay, covalent bonds are always between atoms. And because the bonds are strong, right, you need a lot of energy to overcome. So it requires a large amount of energy to overcome. And then on the other hand, if we look at substance Y, there are weak intermolecular forces of attraction between the molecules. Okay, intermolecular forces of attraction is always between the molecules, okay, in substance Y. So since it's weak, it requires what? Lesser energy to overcome. Therefore, the one that requires more energy will have a higher melting point. Okay, this is how you want to explain your answer. So key points to note. After you state the bonding, right? For example, covalent bonds, you always need to say it's between what? It can be between atoms, between molecules, between ions, right? So you have to state between the atoms in substance X. So if you know what the substance is, you have to be specific. For example, if you know it's carbon, you have to say between the carbon atoms. Then the other example is the weak intermolecular forces of attraction, right? Between the molecules in substance Y. If you know what is the molecule, for example, carbon dioxide, then you have to say between the carbon dioxide molecules. And after that, you have to talk about how much energy is needed to overcome. So if the bonding is strong, right, of course, you need a lot of energy to overcome. If the bonding is weak, you need lesser energy to overcome. And the one that requires more energy to overcome will have the higher melting and boiling point. So that is how you answer part B. Okay, let's look at part C. Explain why substance Z is often used as lubricants. So what are the properties of lubricants? They have to be soft and slippery. So let's explain why substance Z is soft and slippery. So firstly, substance Z we already identify is probably graphite, right? So why is it soft and slippery? One of the properties of graphite is that there are weak intermolecular forces between the layers. Okay, so they are able to slide past one another easily. Okay, take note, graphite has strong covalent bonds between the atoms, but between the layers, there is weak intermolecular forces of attraction. So two different things are, between the carbon atoms is strong covalent bonds, but between the layers, think of it like pancakes, right? Pancakes, they slide past one another, and that is how graphite works. Okay, so there are weak intermolecular forces of attraction between the layers of substance Z. Okay, the layers. So since it's weak, it requires small amount of energy to overcome. Okay, therefore the layers can slide past one another easily, making Z soft and slippery, which can be used for lubricants. Right, so that is how you do a structure and bonding question.